All right, welcome everyone to the first of 2 units over multiple weeks. I don't remember. I think we're doing this in 3 weeks on like an introduction, an introductory introduction to statistics. So we're going to start by talking about collecting data. No math this week. Okay? Put your variables and your numbers away. No math. We're just going to talk about a lot of definitions, a lot of terms, a lot of ideas as we get into this week. Okay, so there's a lot going on here, but basically, I want to teach you statistical literacy. Okay, I want you to know basic things about statistics. So when you're reading about studies and says, "Oh yeah, the statistics say this," or "Oh, there's a statistic of this over here," that you kind of know. What they're talking about, and hopefully you're able to ask questions about the data. Where did it come from? Who's paying for this? How how is the sampling done? All sorts of things to give you some kind of information on how things are done, so you can have a little bit more of an idea of statistical literacy. So there's some introductory things that we don't need to cover in this video. You can read it on your own. But basically, when we say statistics, we mean collecting, organizing, summarizing, and analyzing information so that intelligent conclusions are made. So using data to draw conclusions or answer questions. A lot of people are very good at using data to say whatever they want it to say, but by watching these videos, by participating in these activities and homework, hopefully you're going to be a little bit better at learning how to recognize that and know what all goes into those sorts of things. So we're going to start by talking about populations and samples. Okay, so the short answer is the population is everybody, and the sample is the people that we can ask. Because in reality, we can't ask everybody everything that we want to know. Okay. So, if we want to study the amount of money spent on textbooks by a typical first year college student, our population might be all the first year students at a particular college. But it's very difficult to actually ask every single person in our population. So that's why we cut it down to a sample, which is going to be on the next page. A sample is a smaller subset of the entire population, and ideally one that's fairly representative of the whole population. When we'll cover that a little bit more in a later video. And one other kind of related definition is target population. So sometimes the intended population is called the target population because maybe there's a poorly designed study and the collected data might not be a good representation of the intended population. Okay, so let's do an example. We've got a dentist, and this dentist professor really wants to see, do 4 out of 5 dentists really prefer dentine gum? Did he say that? I don't even know. Over any other gum at his dental school. So the population, what is going to be the population? So it says we're looking about dentists. And this professor cares about dentists at his dental school. That's going to be the population here. Dentists at his dental school. If this problem were phrased a little differently, then we might say all dentists. But really, what is he actually asking about? Asking about the dentist at his dentist school. Maybe he's not going to be able to answer all of them, and he'll, take a sample. But that's it for this one. So a couple more definitions. A parameter is a calculated value, and this value might be an average, it might be a percentage, it might be something else, using data obtained from the population. So this is contrasted. Let's look down here. They're really far away, but look at parameter and look at statistic. Very similar definitions. Statistic is also a calculated value, maybe like an average or a percentage or something, obtained from the sample. So that's just a big thing right here, right? Parameter is information from the population. A statistic is information or a value from the sample. So those are two things, sometimes you're going to be asked, is this a parameter or is this a statistic? They basically are the same thing. It just matters, where did this value come from? Did we ask every student at the college about their first year book, their first year textbook costs? That would be a parameter. Did we ask only some of the students in the first year about their textbook costs? That would be a statistic because it's from our sample. Okay. We're really going out of order with these definitions, but I don't want to just go through them individually. I want to kind of connect them. I'm doing a lot of things with my hands. I'll do them up here so you can see them. Okay, so no, I'm not doing that. A survey of an entire population is called a census. These are nice. We don't have to worry about sampling methods. We get a ton of data if we survey the entire population. The problem with surveying an entire population is it's infeasible a lot of times, right? If we're curious about, let's say I work at a marketing firm or something, and my client asks me, says, hey, we want to know how every single American feels about our company. It would be great if I could say, sure, let me call up every single American and ask them that question, right? You can't ask 300 whatever million people this question, right? So a lot of censuses, censi, I don't think that's the word. A lot of times a census is not feasible, but if you can survey the entire population, again, population compared to sample versus population is a big thing we're going to be talking about. If you can survey the entire population, that would be a census. So, this professor up here probably could ask every single dentist at his dental school. Maybe. I don't know how big it is. Maybe he could. So he or she could, notice that anyway, could do a census maybe. But sometimes the population is just too big. All right, last thing, kind of mentioned this before. A sample is a smaller subset of the entire population. And I have gone through this one. All right, we got two more examples before I can pause the video and collect myself, because myself needs collecting. To determine the average length of trout in a lake, researchers caught 20 fish and they measured them. So the question is, what's the sample in the population of this study? Well, sample is the small subset. The population is everything we're interested in. So we're interested, right, in the entire length, the average length of trout in a lake. Okay, so that's telling us right there about our population. The population is all trout in this lake, and the sample is the 20 fish that were caught. So, we sampled pretty randomly, and hopefully that, might not be that many fish, but hopefully that 20 fish is representative of the whole population. Again, we'll talk about that in a future video. All right, so a college reports that the average age of its students is 28 years old. Is this a statistic or a parameter? Remember, statistic is from a sample, and parameter is from the population. Okay, so always important to remember those. Statistic, parameter. Wow, this is some great drawing with your mouse, Jason. You're welcome. Thank you. So question really is just, is this data coming from the entire population? What is the population? What is the sample? Well, the population is going to be all of the students at this school. There's no sample, right? We're not saying, we looked at the average age of people in Jason's class. No, we're saying the college is saying the average age of all of our students, because the college knows that. All of our students, so this is going to be a parameter. Okay. One of many things the college knows about every single person here. Why is this sounding so creepy? This is data that the college has. Okay, so we got a parameter here. Great. Anyway, that's the video. Good luck getting started. Have fun. I'll see you in the next video where I will be very composed.